Welcome to Inverkeithing High School Maths Department. Today we're going to be looking at equivalent fractions. Now we might not know what that means just yet, but we should do after we've looked at these first three diagrams. The first three diagrams are all of the exact same length, however they've been split up slightly differently based on what fraction I would like to show. So our first fraction has been split up into 8 equal parts as the denominator is 8. However, I'm going to shade 4 of those 8 parts. Our second diagram has been split up into 4 equal parts, and I want to shade 2 of those. And the last diagram has been split up into 2 equal parts, as the denominator is 2, and I've been asked to shade 1 of those. Looking at this diagram then, or these diagrams, we can see that each of them have been shaded in the same amount. So what we can say is that 4/8, 2/4 and 1/2 are equivalent, or another way of saying that is that they are the same. The numbers are different, but they represent the same amount. However, how did I go from 4/8 to 2/4? Well, when we're talking about equivalent fractions, what we need to ensure is whatever we do to the numerator, we must also do to the denominator. So looking at our 4/8, in order for me to go from 4 to 2, I have divided by 2. And in order for me to go from 8 to 4, again, I've divided or halved that. To go from 2 to 1, I have also divided by 2. And to go from 4 to 2, I have also divided by 2. So these are all equivalent because the operation that we are doing to the numerator is the same as what we're doing to the denominator. Looking at some examples then, what you might be asked to do is find out something missing so that you can see what this fraction is equivalent to. So I'm starting with the fraction of 3/6, and I need it to be equal to something over 2. So I need to think about how did I go from 6 to 2? Well, in order to go from 6 to 2, I have divided this 6 by 3. Because there are 3 lots of 2 in my 6. So 6 divided by 3 gives me my 2. Looking then at the numerator, I must also do the same. So I've got 3 divided by 3, which gives me 1. So 3/6 is the same as 1/2. Looking at our next fraction here, we have 5/10. We have 5 over 7 is equal to 10 over something. In order for me to get from 5 to 10, I know I need to multiply that by 2. So if I have multiplied my numerator by 2, I must do the same to my denominator and multiply that by 2. 7 multiplied by 2 is 14. So you can see from both of these examples, equivalent fractions can either be smaller or bigger than the other fraction this is given. So sometimes we will be dividing and sometimes we will be multiplying to find an equivalent fraction. Looking at this next example then, we've got 1 over 5 is equal to 5 over something. So again I'm thinking, how did I go from 1 to 5? Well, I'm going to multiply that by 5. 1 times 5 gives me 5, which means that I need to do the same to my denominator. I need to multiply by 5. 5 multiplied by 5 is my 25. This question here is slightly different to the rest because I don't have a full fraction as my initial fraction. However, the process is still the same. I can think about what do I do to 3 to get to 12? Well, I know I need to do 3 times 4 gives me 12. That means some number times by 4 must give me 4. And the only number that could be is 1. So 1/3 is equivalent to 4/12. I can check that, as I've done before, by looking at my diagrams here. I have got a shape that is the same area, however it's split up slightly differently. So this shape here is split up into thirds. So if I am to shade 1/3, it will take up that whole top row. And if I was to shade 4/12, that would be 4 of these small boxes. I can still see that it takes up the same amount of space, so they are equivalent.